Hi, Dr. Stansel. So this is the final video for week 7, the antibiotic sensitivity Kirby Bauer diffusion test. Mouthful. So I mentioned in the first video I'd get in a little more detail about each antibiotic. So first we use epidermidis or staphylococcus, which we also did a short quiz on that I did today, typed it up, which lives on our skin. And so what this Kirby Bauer diffusion test does is basically we test the resistance of S. epidermidis to 3 antibiotics. So the first antibiotic was penicillin, which is something we've heard of for years and years. Penicillin targets gram-positive bacteria. It disrupts the bacterial cell walls. So we mentioned this before. Basically, the cell's walls, as they diffuse, there's an opening, and penicillin doesn't allow that opening to close back like the mesh-like opening, and so the water rushes in and the cell is burst. And penicillin is produced by mold. Okay, so it's a narrow spectrum antibiotic. It only kills the selective group. So number 2, the second antibiotic disc that we use is novobiocin. So it also targets gram-positive bacteria. The way it works is it basically stops replication of growth. It disrupts the DNA process when things are when they're being replicated, and so basically the cells die off because they can't replicate. So it basically doesn't really kill them, but inhibits their growth. And by inhibiting the growth, they can't keep growing, obviously, and then they die off. So the last one is gentamicin, and it targets aerobic gram-negative bacteria. So it binds with bacterial ribosomes, so they can no longer synthesize, so they can't grow and divide, and that's how that kills bacteria. Now, I have to type up an error, 2 errors in my paper, because number 1, which may or may not affected things, my agar plate is uneven and it also has bubbles, and I'm thinking that the S. epidermidis broth maybe was uneven, and so it didn't evenly spread, which can influence the antibiotic disc. But number 2 is, I think there is a contaminant. And why do I say this? Well, I'm going to show you why I say this. First, S. epidermidis is a gram-positive bacteria, right? So that means it should either be killed by the first 2 antibiotics, penicillin or novobiocin. However, in my results, the only inhibition that has been shown is from gentamicin, which kills gram-negative bacteria. So totally different turn of events. So let me see if I can show you, because it's kind of difficult to see. I'm going to face this down here. I have a dark background and there's light reflecting. So maybe if we turn off the light, we can see. I'm not sure. This is a dark background, and then I also used a white background, but basically what shows it is up close and personal. You can see the fuzziness around penicillin, haziness, and also around the novobiocin, and then around gentamicin, see there's inhibition of growth. So I have to say, what the heck did I do wrong? Because I definitely didn't think that was going to be the answer. But there is inhibition of growth. And I noticed these 2 didn't do too much. This one has a little inhibition of growth on the side, but not much. So I'll definitely report this. What does this say? Well, besides being contaminated, the point of this test is to see what stops this pathogen, right? And so it's fascinating to me they use this in hospitals. So Dr. Stansel, let me know what you think about this, because it's quite interesting. that this particular antibiotic, gentamicin, stopped the S. epidermidis and the rest did not. Thank you.